This is video 30. In this video, we explain how to build a long fork. This result is in two parts. First, we look for a path called a trajectory. This path will be the underlying path of the long fork. Consider the setting of the previous video. We consider a path assembly P producible by a tile assembly system. We also consider a visible candidate segment of P of direction V and its free zone F. The window of the free zone is W and it is drawn in gray. Consider the segment of the window from index 0 to index M. This segment is in blue. This segment is also the underlying path of the segment of the path assembly P from index I1 to its last tile. We can use some parts of this blue path to build our trajectory. Now consider the segment of the window from index N to index M. This segment is in blue. And consider the translation of this segment by -V. This translated segment is in red. The first position of this red path is W0. The trajectory will be defined by using some parts of this red path and some parts of the previous blue path. Consider the decomposition of this red segment in extreme arcs in the free zone. Remark that the arc A7 is negative. Thus this decomposition is not positive. This fact may be troublesome in the future. Then, a little trick is needed in order to obtain a positive decomposition. Instead of considering the segment of the window from index N to index M, consider the segment of the window W from index N to plus infinity. This infinite path is in blue. Now, consider the translation of this infinite path by -V. This infinite path is in red. Now we aim to show that the decomposition of this path is positive. First, consider the segment of the window W from -infinity to -1. This segment is in yellow. Suppose that the red path intersects with the yellow one. In this case, the translation of the red path by the vector V intersects the translation of the yellow segment by the vector V. By definition, the translation by the vector V of the red path is the underlying path of the path assembly of P, and thus the tile Pi2 is not visible from the west, which is a contradiction. As a corollary of this result, the red segment starts at position W0, and there exists an index J2 such that the extremum path extracted from the red path is the translation by -V of the segment of the window W from index 0 to index J2. Now, consider the window W second associated to the red path and its cut of the grid G5 and G6. Remark that the translation by -V of the segment of the window W from index J2 plus 1 to plus infinity belongs to the graph G6. We have proven in the toolbox that, in this case, the decomposition in extremum arcs of red path in the free zone is the same one as the decomposition in extremum arcs in the free zone of the translation by -V of the segment of the window W from index 0 to index J2. Now, consider the decomposition of the red segment in extremum arcs in the free zone. This decomposition is the same one as the decomposition of an extremum positive path. Thus this decomposition is positive. In our example, this decomposition is made of 7 arcs. Consider the dual decomposition of the window W associated to this decomposition. This dual decomposition is made of 8 segments of the window. These dual segments are in blue. Consider the window W prime associated to the decomposition and its cut of the grid G3 and G4. This new window is in gray. Consider the smallest index J1 such that the position of the window W prime at index J1 is east of the last tile of the path assembly P, or such that the translation by the vector V of the position of the window W prime at index J1 is east of the last tile of the path assembly P. The trajectory is defined as the segment of the window W prime from index 0 to index J1. This trajectory is in green. Consider the window W again. By definition, the trajectory is a subgraph of the free zone. Also, this trajectory is made of parts of the blue and red paths. Thus the last hypothesis to check is that its translation by vector V of the trajectory is a subgraph of the free zone. Consider the translation of the trajectory f by the vector v. In our example, this path is a subgraph of the free zone. We now prove this result. The trajectory is made of some arcs of the decomposition. The translation of these arcs are in red. By definition, the translation of these arcs by the vector v are segments of the window W. Thus they are subgraphs of the free zone. The trajectory is also made of some dual segments of the window W. The translation of these dual segments are in blue. The translation of these dual segments are on the west side of the underlying path of the path assembly P. This result was proven in the toolbox. If the position of the translation of one of these dual segments is east of the last tile of the path assembly P, then this position is the last position of the trajectory. If a position of the translation of one of these dual segments belongs to the segment of the window W from -infinity to index n-1, then a position of the translation of this dual segment is west of the tile Pi2. In this case, the tile Pi1 is not visible from the west, which is a contradiction. Thus the translation of the trajectory is a subgraph of the free zone. Thus the trajectory satisfies all the hypotheses to be the underlying path of a long fork. Now we explain how to assemble a path assembly whose underlying path is the trajectory. Consider the trajectory f. Consider the translation of the trajectory f by the vector v. Consider the translation of the arc A1 by the vector v. This translated arc is a segment of the window which starts at position Wn. Then the first tiles of the fork are the tiles of this red segment. Now consider the trajectory f again. Consider the dual segment D1. Now since the tile assembly system is deterministic, then the fork can be extended by adding the tiles of this blue segment. Consider the translation of the trajectory f by the vector v again, and let's keep doing these operations again. Finally, a long fork f has been assembled. Note that these operations have been possible because the decomposition is positive.